All right. You know how sometimes you're talking to your voice assistant?
Uh-huh.
Like maybe you're asking for a recipe or some help with like
Yeah.
a home improvement project.
Yeah.
And it just totally doesn't get what you're saying.
Yeah, we've all been there.
Well, this deep dive, we're looking at a paper that tackles that problem.
It's a really interesting approach, actually.
Ah.
Instead of just trying to improve the speech recognition itself,
Okay.
it focuses on using the context of the whole conversation to figure out what you meant to say.
So even if the speech recognition gets some of the words wrong,
Right.
the system can still figure out what you were actually going for.
Exactly. Like it's understanding the bigger picture.
Okay, I'm intrigued. Tell me more.
So this paper proposes a new method for correcting errors in automatic speech recognition.
ASR.
ASR, yep. Specifically for these goal-oriented conversational AI systems.
Okay.
And it uses large language models, LLMs, to augment the system's understanding of all the different ways a user might phrase a request.
So instead of just relying on like a limited set of pre-programmed commands,
Right.
it can actually learn and adapt to the way real people talk.
That's the idea.
That's super cool.
Yeah, and the researchers actually tested this on Amazon Alexa.
Oh, wow. Real world stuff.
Yeah, focusing on those tasks related to cooking and home improvement.
Makes sense.
They collected and annotated real user dialogues.
So they're working with the messiness of the way people actually talk.
Exactly.
I mean, I've definitely had my fair share of frustrating moments where Alexa just completely missed the mark.
You and me both, and that's exactly what this paper is trying to address.
Right.
And they point out that these errors are especially common during that task search and selection phase.
Which makes sense. That's like a core part of using any voice assistant.
Exactly.
So like if I'm trying to find a recipe for salsa, but I mumble something that sounds more like salted,
Yeah.
this system would ideally be able to figure out that I probably meant salsa because we're talking about cooking.
You got it. So to actually do this, they use a combination of some pretty clever techniques.
Okay, lay it on me.
First, they identify what they call the dialogue state.
Dialogue state, what's that?
Basically, figuring out where you are in the conversation.
Okay.
Are you searching for a task? Are you choosing from options? Or are you already in the middle of following instructions?
So like it's figuring out the flow.
The flow, yeah. So if the system just asked me, do you want to make salsa or guacamole?
Yeah.
It knows that my response is probably going to be related to those two options.
Right.
So they call this creating a narrow context.
Narrow context.
Which is essentially a list of expected user responses based on that current dialogue state.
Okay.
So it could include things like variations of the options presented by the system, common commands, or even just partial phrases.
So it's like the system is kind of anticipating what I might say.
Right, based on where we are in the conversation.
That's pretty smart.
And then once they have this narrow context, they use two main ranking methods to try to match what the user actually said with what the system expected them to say.
So they're trying to connect the dots between my actual words
Right.
and the system's understanding of the situation.
Exactly.
Cool. Tell me about these ranking methods.
So the first one is called re-ranking ASR hypotheses.
Re-ranking ASR hypotheses.
Yeah, so it basically looks at the top few things the speech recognition thinks you said,
Okay.
and it scores them based on how well they match that expected context.
So it's considering both how similar the words are.
Right, lexical similarity.
Lexical similarity.
And how similar the meaning is, semantic similarity.
So it's not just about like a one-to-one word match.
Right.
It's about actually understanding the intent.
The intent, exactly.
Yeah, that's a big step forward.
And for this part, they use a really cool technique called sentence-BERT embeddings.
Sentence-BERT embeddings. What's that?
It's basically a way to give each sentence a unique fingerprint based on its meaning. So it allows the system to compare sentences and see how semantically similar they are.
So it's like it gives the system this deeper understanding of language.
Deeper understanding, yeah.
Not just that surface level word matching.
Exactly.
Now, what happens if none of the speech recognition's top guesses are actually a good match?
That's where the second ranking method comes in.
Okay.
So if that initial speech recognition output just seems totally off,
Yeah.
they try to find a task or option in their database that sounds phonetically similar to what the user said.
Oh, so even if the words themselves don't match up perfectly?
Right.
Gotcha.
So like if you said something that sounded like fix a leaky basil,
Okay.
and the system doesn't recognize basil in that context,
Yeah.
it might search for things that sound similar, like faucet.
Oh, and they'd be like, oh, they're probably trying to fix a leaky faucet.
Exactly.
It's really clever.
And this is especially useful when the speech recognition is garbled but still contains some recognizable sounds.
So they're really trying to cover all their bases
Yeah.
and anticipate all the ways that speech recognition can go wrong.
We're all human, right?
Right, but what about those cases where the user uses a phrase that the system has never heard before, or the speech recognition just completely butchers a word?
You're right. Those situations are a challenge.
Yeah.
And that's why they've developed some techniques for what they call augmenting context.
Augmenting context.
And they do this in two main ways: offline LLM augmentation and using partial matches.
Okay, let's hear about these context augmenting techniques.
So for offline LLM augmentation, they basically use a large language model, in this case GPT, to generate additional variations of the tasks and options they already have.
Okay.
So this way, the system has a much richer data set to work with and can better understand the nuances of human language.
So instead of just having how to fix a leaky faucet in their database,
Right.
they might also have repairing a dripping faucet, fixing a faucet that's leaking, and so
Yeah,
on.
exactly.
So even if I say something slightly different, the system can still understand what I mean.
Precisely. And they do this offline,
Off.
which means all these variations are generated ahead of time and ready to go when the system needs them.
That's smart, because doing all that language processing in real time would probably take forever.
Exactly.
Okay, what about partial matches? What are those all about?
Partial matches are all about dealing with missing words.
Okay.
For example, if you're in the middle of a conversation about plant care
Mm-hmm.
and you just say water,
Yeah.
the system might be able to correctly infer that you mean how to water indoor plants.
So it's like the system can fill in the blanks based on the context.
Yes, and it's also helpful for handling those situations where we naturally omit words that are implied by the situation.
Right, like instead of saying, I want to learn how to build a wood fence,
Yeah,
you might just say, build a fence,
exactly.
and the system should still be able to understand.
Right.
That's pretty impressive. They seem to have thought of everything.
Well, they're trying to.
But did they actually put this to the test?
They absolutely did, both in offline evaluations and with real users on Amazon Alexa.
Oh, wow. And the results are really promising.
That's great. So in their offline tests, they found that their method significantly improved the system's ability to correctly identify the task the user was trying to perform,
Even when the speech recognition made mistakes.
even when the speech recognition made mistakes.
That's great. So it actually works in practice,
It does.
not just in theory.
Not just in theory. They actually had users interact with the system and rate their experience.
Yeah.
What's remarkable is that even when the system offered a correction that wasn't quite right,
Okay.
the user ratings didn't drop significantly.
So even when it wasn't perfect, people still appreciated the effort.
They did. It seems like they struck a good balance between being helpful and proactive
Yeah.
without being too intrusive or annoying.
I can appreciate that.
Yeah.
This is all really fascinating. It definitely feels like a big step forward in making voice assistants more reliable and user-friendly.
It really does.
I'm curious to hear more about the details of their experiments and what they learned from that user study.
Yeah, for sure.
Maybe we can dive into those aspects next time.
Absolutely. There's still a lot to unpack here.
Well, then I guess that means we'll have to pick up where we left off in part 2 of our deep dive.
Sounds like a plan. Welcome back.
So last time we left off talking about how this new system was actually tested in the real world.
Right. Yeah, we were about to dive into those details.
Okay, remind me again, how did the real world test work?
So they actually deployed the system on Amazon Alexa
Oh, wow.
and had real users interact with it.
And you mentioned that they tested this in 2 domains, cooking and home improvement.
Yeah.
Why those 2 specifically?
Well, those are two areas where people commonly use voice assistants to try to accomplish specific goals.
That's true.
Like, think about it. You might ask for a recipe while you're in the kitchen
Yeah.
or need instructions on how to fix something around the house.
Right, makes sense.
And those are tasks where clear communication is really important.
For sure. Even a small misunderstanding can lead to a lot of frustration.
Exactly. And the researchers wanted to see how their system would perform in these real-world scenarios.
But the user input can be really messy and unpredictable.
Yeah, exactly.
Okay, so how did they actually measure how well the system was doing?
They had users rate their experience on a 5-point scale.
Okay.
And what's really interesting is that even when the system offered a correction that wasn't quite right,
Okay.
a so-called false positive.
Hold on. Back up for a second. What exactly do you mean by a false positive in this context?
So a false positive is basically when the system thinks it needs to correct an error,
Okay.
but the user actually said what they meant.
So it's like when your email spam filter accidentally flags an important message as junk mail.
Yeah, exactly.
Gotcha.
So even when the system made those kinds of mistakes, the user ratings didn't drop significantly.
So people weren't getting super annoyed.
Not at all. In fact, the users often found the system's attempts to clarify what they meant to be helpful,
Even when those attempts weren't entirely accurate.
even when they weren't entirely accurate.
That's really interesting and suggests that the system isn't just like being intrusive
Right.
and second-guessing people all the time.
It's more like it's offering helpful suggestions
Yeah.
and trying to make sure it's on the same page as the user,
Exactly.
which is a really important aspect of good user experience design.
For sure.
It's not just about being accurate.
Right.
It's also about being helpful.
Yeah.
And understanding those nuances of human communication.
It seems like they've really thought this through
They did.
and done a good job of balancing that accuracy with user-friendliness.
Yeah.
But I'm curious, what were some of the specific challenges they faced when developing this system?
Oh, there were definitely challenges. One of the biggest was dealing with the sheer variability of human language.
Human language is messy.
It is.
It's not like talking to a computer where you have to use very precise commands.
Right. People have different accents. They use different words to express the same idea.
Uh,
And they often leave out words or phrases that are implied by the context.
yeah, and that's why they had to get creative and develop these techniques for augmenting the context
Yeah.
and ranking those potential interpretations.
Right. It's all about making the system more robust
Yeah.
and adaptable to the way real people talk.
And you mentioned earlier that they used GPT to help with this, right?
Yeah, so they specifically used GPT 3.5 Turbo to generate variations of tasks and options offline.
Offline.
Yeah, before the user even started interacting with the system.
Dope.
This allowed them to create this much richer database of potential interpretations
Okay.
without slowing down the system's response time.
It's like they're preloading the system with all of this linguistic knowledge so it can respond more quickly.
Exactly.
So they've got this system that understands context, ranks possibilities, and even uses GPT to expand its knowledge base. But I'm curious, what are some of the limitations of this approach?
That's a great question.
Are there cases where it might not work so well?
Well, one potential limitation is that the system relies on having this well-defined set of tasks and options to work with.
So it's great for those goal-oriented scenarios that we've been talking about.
Like cooking or home improvement.
Right, where the range of possible user requests is relatively limited,
Yeah.
but it might not be as effective in those more open-ended conversations.
Like discussing current events or personal interests.
Exactly, where you don't really know what someone might say.
Right. But what about those situations where the user is trying to do something completely new or unexpected? Like, what if I wanted to use my voice assistant to control a robot that walks my dog?
Now, that's a really interesting question.
Yeah.
And it highlights this key challenge in AI research.
Which is?
How to create systems that can handle those truly novel situations.
Not just variations on things that they've already seen before.
Exact.
So this research is a step in the right direction.
It is.
But we're still a long way from having voice assistants that can truly understand and respond to anything we throw at them.
That's right. But it's important to remember that progress in AI is incremental.
It's a process. It is. And each new research paper builds upon the previous work,
Right.
pushing the boundaries of what's possible.
Yeah.
And this paper, with its focus on context awareness and error handling, is definitely a valuable contribution.
Absolutely. And it's not just about making voice assistants better.
Right.
These techniques could have applications in all sorts of other areas.
Absolutely. Anything that involves natural language processing,
Chatbots.
chatbots, machine translation, even analyzing social media data could potentially benefit from these advancements.
Wow, it sounds like we're on the cusp of some really exciting developments in AI.
I think so.
But before we get too carried away with all of these future possibilities,
Yeah.
I think it's time for us to move on to our Novel Notions segment,
All right.
where we'll explore some of those more speculative ideas inspired by this paper.
I'm game. Let's get those creative juices flowing.
All right, it's Novel Notions time, which means it's time to get a little bit speculative.
Exactly. We're going to take the ideas from this paper and kind of stretch them, bend them a bit, see where they might lead.
Sounds fun.
So last time we were talking about how AI could learn our personal speaking quirks and maybe even start to anticipate our next move.
We were. Those are some pretty big ideas.
Yeah, but what if we pushed it even further?
Okay, I'm listening.
What if we combine this context-aware error handling with something else that's been making waves lately? Emotion AI.
Emotion AI. Wait, are we talking about like making AI that can actually feel emotions?
Hold on. Not quite feel emotions, at least not the way we do.
Okay.
But what if AI could recognize and respond to our emotions?
Okay, so my voice assistant wouldn't just be listening to what I'm saying,
Right.
but also how I'm saying it.
Exactly. It could pick up on those cues like tone of voice, word choice, even pauses and hesitations.
So if I'm snapping at my voice assistant because I'm just having a bad day,
Yeah.
it wouldn't take it personally.
Exactly. It could recognize that frustration and respond accordingly.
So what, like use a more soothing tone?
Maybe, or even suggest something like, would you like to listen to some calming music?
That would be amazing. It would be like having a voice assistant that's also a bit of an emotional coach.
Right. And here's where it gets really interesting.
Okay, go on.
What if this emotion-aware AI could also use its context awareness to actually figure out why you're feeling a certain way?
Give me an example.
Okay, let's say you're getting frustrated with a cooking task.
Happens all the time.
The AI could not only recognize that frustration, but also consider the context?
Like maybe I'm trying a complicated recipe for the first time.
Right, or you're running short on time.
And then it could offer more specific advice based on that understanding.
Exactly. Like, hey, it sounds like you're feeling overwhelmed. Would you like me to suggest a simpler recipe?
Or offer to set a timer for me. Or even just remind me to take a deep breath.
Exactly. It would be like having an AI sous chef who's also a therapist.
That's amazing, but we can't forget about the potential downsides here.
You're talking about privacy?
Yeah, I mean, we don't want our voice assistants spying on our emotions and then selling that data to advertisers.
You're absolutely right. That's why any research in this area would need to prioritize privacy and ethical considerations right from the very beginning.
Maybe there could be like a way to opt in or out of certain levels of emotional analysis.
That's a great idea.
Like I could choose to share some basic emotional cues with the system,
Yeah.
but keep my deepest, darkest secrets private.
Yeah, and it really highlights how important it is to involve users in the design and development of these systems.
So it's not just about making the technology work.
Right.
It's about making it work for people in a way that respects their values and boundaries.
Exactly.
This is starting to feel like a pretty big, complex topic.
It is.
It's not just about tweaking algorithms anymore.
Right.
It's about thinking deeply about the relationship between humans and AI.
And that's what makes it so fascinating. We're not just building tools.
Right.
We're shaping the future of how we live, work, and interact with the world around us. And that includes our own emotions.
Well said. I think this has been a really thought-provoking deep dive.
Me too.
We've gone from fixing voice assistant errors to basically reimagining the nature of human-AI interaction.
It's amazing what can come out of exploring even just one research paper.
Absolutely. And all of this started with this simple problem of how to make our voice assistants understand us a little bit better. It just goes to show that even those seemingly small research questions can lead to some really big, profound insights.
You said it.
And on that note, we've reached the end of our deep dive into this fascinating paper on how to make AI understand us better.
We hope you enjoyed it.
We'll be back next time with another deep dive into the world of AI.
Until then, keep those brains buzzing.